In this video, we're going to talk about U-substitution. So this is the case when we have the integral of f of g of x, and on the outside we get g prime of x dx. So we use the character or letter u equal to g of x. So we take the derivative on both sides. So we'll get that du dx equals g prime of x. So derivatives are not really fractions, but you can multiply both sides by dx in a way. So this will be that du equals g prime of x dx. And so basically we have a u equal g of x. We can take the derivative on both sides with respect to its variable. So the derivative of u is just du. The derivative of g of x is just g prime of x dx. So you kind of do it on both sides. So when you plug this in, you'll get the integral of f of u. So g of x is u. And then you have that g prime of x is du. So this is u and du. So this would be just the integral of f of u du. And let's just say this is f of u, capital F of u. And then at the end you plug it in. So u we know is g of x. So you just get capital F of g of x. And then you add c. And this is the way you do u substitution. So let's do an example. So you have the integral of x minus 3. Let's put 2x minus 3 cubed dx. So we'll let u equal 2x minus 3. Du equals 2 dx. So you can do 2 minus 0 dx, which would just be 2 dx. So you can skip to this part. And we want to get dx by itself, so we can divide by 2. So we get dx equals du over 2. So this will be the integral of u cubed. 1/2 goes on the outside, and then du. This would be 1/2 u to the 4 over 4, which is 1/2 times 2x minus 3. So u is 2x minus 3 to the 4 over 4. And then add c. And 1/2 and the 4th can cancel to be 1/8. So this is the answer. So that's u substitution.